The presenter for today's OLL live session is Eduardo Moranchel. Eduardo is a curriculum developer in the Server Technologies Curriculum Development Group here at Oracle. At this time, I'd like to turn it over to you, Eduardo.
Okay, thank you, Peter. Hello, everyone, and welcome to this online course about Java EE 7 consuming RESTful JSON services using Jax-Rs 2.0. My name is Eduardo Moranchel. I'm a Java curriculum developer at Oracle. I'll be guiding you through this webcast, which consists of creating a web-based application that already uses HTML5 and WebSockets to use JSF 2.0 for to use Jax-Rs 2.0 for remote calls to a REST service. The goal of this is to demonstrate the new features that are available on Jax-Rs 2.0. On this slide, we have our standard Oracle Safe Harbor notice. Basically, it states that this webcast does not require a contract between us, and what I'm demonstrating today should not be used to make any purchasing decisions. Have a second to look at it. Okay. To take full advantage of this webcast, you should have the following prerequisites. A poll will be posted on your screens asking you for your experience with some of these technologies. You need to have some experience with Java Enterprise Edition development, specifically HTML, JavaScript, and Java server faces. Note that in order to follow this tutorial, you also need the following Oracle products. You need NetBeans 7.3.1 for Java EE 7, and the GlassFish Server Open Source Edition version 4, which is a Java EE 7 compliant server. These are available for download at netbeans.org and glassfish.org, respectively. Java EE 7 is built thinking in three main themes. One, developer productivity, to enable developers to write applications faster with easier configuration using annotated objects. It reduces the boilerplate code required for common tasks, and having a cohesive, integrated platform to develop applications. Meeting the enterprise demands with APIs for batch, jobs, concurrency, and as well as simplifying existing APIs like JMS. And finally, HTML5 support with inclusion of WebSockets, JSON, and improvements in the Servlet API, more REST web service support, and finally, many improvements in JSF. Jax-Rs 2.0 includes three new features. Asynchronous support to handle requests in the server or clients. This will optimize resources in your applications. In the servers, you can write the response on separate threads, and in the clients, you can use callbacks or blocking future objects. Filters and interceptors for REST calls integrated in the server and client calls. This allows a unified way to create filters and interceptors. And a client API to call RESTful web services in your applications. This API allows you to communicate your application to services using a simple yet extensible API optimized for REST calls. Note that Jax-Rs support code is reusable in clients and servers. So most of this asynchronous support and filters and interceptors, you may find that is really portable when you use it on the server and on the client. I will give an overview of how do you create a Jax-Rs calls asynchronous servers. Asynchronous server support in Jax-Rs works in the following manner. You have to add an async response parameter to your Jax-Rs service methods. Then, using this method in a separate thread, you can write a response using the resume method. And the code snippets are examples here of how do you use this asynchronicity in your Jax-Rs 2.0 servers. So start your request method, you add the async response, then you end your method. And in a separate thread, you write a response. Here you have the code snippets for both. Asynchronous clients works with callbacks or blocking future objects. You have to add the async response parameter to your Jax-Rs service methods. Sorry, no. You have to make the client request asynchronous, you have to call the async method on the request and then calling the service method and a callback. You have to create a request as normally on your clients. You have to make it asynchronous and then call the method with a callback, the request method with a callback. Or if you desire, you can use a future object. Then let's move to the next one. And finally, the other feature that has Jax-Rs 2.0 is interceptors and filters. Interceptors and filters are created using Jax-Rs providers that implement specific interfaces. Filters are applied to the request and to the response, while interceptors are applied to the actual content of the request or the response. In this slide, you can see how what is the execution order of interceptors and filters. So these are the 4 interfaces that you use for filters. These are the 2 interfaces that you use for interceptors. So first happens the client request. A client makes a request. Then there's a request filter for every client. And then there's the interceptor for writing the request. Then the server receives that request. There's a request filter for the container or the server. And then the interceptor reads that from the request. So you can see here, there's a write interceptor, there's a read from the interceptor. Finally, there's a response from the server after the method invocation. There's a response filter after the response is going to be sent, and then there's an interceptor to writing the content. Then finally, the client receives the response. There's the response filter, and then the interceptor. Then the final feature added in Jax-Rs 2.0 is Client API. The Jax-Rs 2 Client API provides a simple alternative for invoking RESTful services on a remote server. The API was created thinking of REST, so you have unprecedented flexibility creating REST calls. You can add query parameters, form content, and other useful REST features to your client calls by chaining methods as shown in the second example here. And optionally, you can enable features in the invocation chain like asynchronous processing. Using this API, you can create simple one-line REST calls by using method chaining or create templates by saving an object in the chain for reusable calls. So as you can see, you have to create clients, web targets, requests, and then you can actually extend or save the method, the objects in the chain as you see fit. And also you can add features optionally, like creating them asynchronous and then calling your HTTP object call. So in the demo, I'll show you how to create Jax-Rs clients using the new features. The application we are going to be looking at uses JSF, servlets, WebSockets, and we will add Jax-Rs clients in each of these technologies. Let me share you my desktop. So in this demo, I begin with 2 applications, a REST server and a web application that will actually consume the REST services provided by this other application. The REST server application uses Jax-Rs, and I will update it to use the JSON processing API for the data that will be sent to the first application, to the web application. The web application itself uses JSF, servlets, and WebSockets from E7. I will update it to use Jax-Rs 2.0 clients and JSON processing. The application I will be showcasing is the same that I've been using in the other webcasts. So let me show you. It's a sticker book application. Users have a set of stickers in the left side of the screen, and they can drag them to the canvas in the right side. The interaction is done with WebSockets, and the page itself is a JSF page. So here's the application. Here you have the list of stickers. You can drag them to the right side. And right now you're not seeing anything because we haven't implemented this part. Because the data, well, the data in the original application was saved in memory. In this webcast, the data itself is on a REST server. The web application will connect to the server to get the list of stickers and send the stickers that have been dragged to the canvas as well. So all the data management will happen on the REST server. The REST server itself has been implemented already, so we have some basic stuff. I will demonstrate that as well. And as you can see, we don't have any stickers on the left pane of the page. So the steps I will follow, I will implement the required code to show the stickers here from the REST server. I will get also the sticker images from the REST server and display them over here. And finally, I will retrieve all the stickers that have been dragged here, and I will save every sticker that is being dragged from the left side to the right side. So first, the list of stickers is generated in the REST server by a class that is over here, which is the sticker resource class. The sticker resource class is a classic Jax-Rs object. So we have the usual stuff. We have the path for this resource, and we have some methods. You can see I have these methods already existing. I have the method that will return me the list of images, and a method that, given a name of a sticker or an image, will get me the actual image itself. So what I want to implement first is this method here, getting the list of images. The list of images is already over here in a list. So I want to return REST JSON representation using REST for this list over here. So let me show you how do we do that. In Jax-Rs 2.0 and in Java E7, you have the JSON processing API already. So you can actually return JSON objects in your Jax-Rs methods, and they will be serialized as JSON strings automatically. You just need to add the produces application JSON add annotation, and then return the JSON array object. So how do I create a JSON array? Well, I just have to do JSON array, array builder, JSON array builder equals JSON dot create array builder. I fixed my imports by going to source, fix imports, then works. And then I have to use this builder to construct the array, the JSON array that I will be using. So what I will be sending is just the strings themselves in a JSON array. So I don't have to write any really complicated code. So I will just go string image name inside image names. So I will iterate my list of images, and I will add them to my array builder. So array builder dot add, and I will just get the image name. There we go. Finally, I have to return the actual JSON array. So I have here a builder that I can use to create the actual array, the actual JSON array. So I will just do an array builder dot build, which actually will return me a JSON array object, which is the one that I need. So if I fix my formatting and save the file, I can actually access this stickers resource from my browser. So let's go to the browser. Here I have the server, so I can access the rest/stickers, and there it goes. I get the list of stickers that I have available right now on the application. So this actually will serialize the images that I have into a JSON array, and will return it in my JSON in my REST in my REST service here, this URL. So let's try to see the actual images of one sticker. So I can see that I have another resource down here, which has the path as the name of the image, which will actually give me a subpath of stickers slash the name of the image, and it will actually use some kind of actually REST conventions to give me the actual image itself. So I know that there's an star.png, so let's try to see that one, star.png. And there we have it. There we have a star. So right now we know that we have the service that will give me the list of images that I have, and I have my service that will give me a particular image. So I can actually move forward and add those to my web application. So actually in the server side, I'm just finished. I have everything that I need. I have the service that will give me the list of images, and the service that will give me a particular image. This is already there built, so I just want to demonstrate the JSON functionality. So let's move to the web part, to the web application. So the list of images is actually a JSF managed bin. The JSF managed bin is a sticker sheet object. It's a managed bin from JSF, which actually will return me a list of the stickers available only. If I want to show you the JSF page that actually shows this part, so the JSF page contains only a URL repeat element that will iterate over all the stickers inside the sticker sheet object. Here is managed bin, and will use the HTML5 features from JSF to show me the stickers. So here I have the stickers shown each one. So I will go into this further because this uses servlets to display the actual image. So first we need to actually get that list of stickers, because right now I don't have anything. I don't even have broken links or anything, so nothing is being shown here. I want to show at least broken links. So let's go to the sticker sheet class. And here I have the get all stickers method, which is called by JSF. I want to return here the list of images that I actually have, which I will get from this REST service over here. So the first thing I need to do is I need to create the call that I will use for making a RESTful call. So I will create the list of images that I want to return as stickers, because right now I'm returning a null. So new array list. Let's get it really simple. So, and I will return those things. Then the next thing I need is to create the actual REST call. So to create calls, as I showed you in the slides, I have to create a client, then a target, then a request, and then finally calling the method that I need. So first, I need a client. So I create a client equals client builder dot new client. There we go. I fix my imports. I use the Jax-Rs client class, and then I'll just now that I have the client, I have to tell the client that I want to keep as a specific service. So say client dot target, and here I can keep the URL that I want to actually query. So I already have that. It's here. It's this REST service. So I actually copy this URL. I will paste it over here, and this will give me, as a result, a web target. So there we have it. I fix my imports again, and then I get the Jax-Rs web target object here. Then with this web target, I can actually make a request. So I can actually do target.request. And in the request, I can say what media type I am expecting. So Jax-Rs contains this media type interface with a lot of constants that are actually are the most used media types over there. So I can look here for the application JSON media type, and then just make the actual request. So I know it's a GET request, so I will do GET, and I actually know the object that I want as part of this GET. I know that I have to get a JSON array from here. So I do this JSON array response equals this. So just as I did with the sticker resource, transforming this array list into JSON objects, I will do the opposite here. I have the JSON objects, and I will convert them to the list that I have here. So it's really simple. I will copy this code from here. So I will iterate over each of the elements inside the JSON array. I know already that they are all strings, well, and they are just separated by commas and everything. So instead of actually, I cannot get the string directly here. I have to get the JSON value, which is a kind of wrapper, a super interface that will, and that each value will extend this interface. Then I will get the JSON string and get the actual string from here. It's actually the syntax you use in JSON processing to get the actual value of each element in your array. If you send an array of objects, you will have to use a JSON object instead of JSON string. If you send numbers, you will have to use JSON number instead of JSON string as well. So let's go back to our application. If this worked, then we should actually see some broken links on the left. Actually, let me open it in Explorer because that one is the one that actually displays those broken links. There you go. You can see that I have now broken links here because I am requesting the list of stickers, but I am not requesting the actual picture for each sticker. So that's my next step, is to actually display those images. Let's go back to the DSF page. So I am doing this. I am getting all the images and I am repeating, iterating them. So inside of each image, I use a servlet to display the actual sticker image. And the actual sticker image is inside my REST server here. So what can I do to actually display this image from my REST server using a servlet on my web application? Well, let's open that servlet. I see that it's completely empty, so that explains the broken links. Well, I can do a REST call inside my servlet that will actually get me the image from the REST resource that I have there. So I can actually get the images from another server inside my server, so I can actually disguise the fact that I don't have those images and actually get those resources from elsewhere. So let's go to that class. In order to do so, here's a note. You're going to make a lot of requests here to your application. You will make one request per each sticker that you have here to a remote server. This will require this servlet to be called a lot of times, and that will mean poor performance in your side. It's actually kind of a performance issue you will have. This tutorial will be available in the Oracle Landing Library site. And if you want to try it, try removing the asynchronous part in this servlet and see how the impact in your performance is. So the first thing that I know that can help me with the performance issues that I have is using asynchronous support for Jax-Rs and for servlets. So I will add the asynchronous support for servlets now. I do that by modifying the web servlet annotation and adding the async supported through a parameter here. This doesn't make everything asynchronous. I have to actually do it myself. So let's actually look at the code required to make an asynchronous call. To make an asynchronous servlet, I have to start an asynchronous processing here by calling request.startAsync. This will return me an async context, async context object. With this, I actually say, okay, my request will be handled elsewhere, not here. Someone else will handle it. Okay, so right now, what I can do is start creating the Jax-Rs call that I actually need. So I know that I need to connect to a client as usual. Client builder dot new client. So I create my client. I fix my imports. I know the URL I want to hit. This is I get this from this URL here. I know that it has to be localhost something, and then the name of the actual image that I want. I know that image. I receive it as a parameter, the parameter name here for my servlet, so I can actually use this guy over here. So let's copy this. So I know that it is a string URL. I have to hit something like this with some quotes. And I know that instead of star PNG, I have to do request.get parameter and get the parameter name. There we go. Then, now that I know the URL that I want to hit, then I have to create a target, client.target. And just this target, I will actually say, okay, the URL that you are going to hit is the URL that I declared up there. So web target equals this. And now I start my request, right? So target dot request. Fix imports. Dot request. I know that I will be receiving an image / PNG file from my REST server. And here's where the fun begins. I know that I have to handle this asynchronously. So I have to do this request asynchronous. I do that by adding the async method call in my chain, and then I know that I will be calling a get. Which one of these will I will use? I will actually use this guy over here, the get with an invocation callback. So get, and I will create a new sticker callback class. And I will send it the async context. So what happens over here? I will create this class right now. This class will be called, will actually implement the callback interface that I need. And I will send the asynchronous context from the servlet. So whenever this RESTful call answers and returns me data, I will actually call the methods inside this sticker callback object. So let's do that. I will click over here, and I will create the class sticker callback with constructor. There we have it. And here we just have to implement the correct interface. The correct interface is called invocation callback. Well, actually remove this. Invocation callback. See, we have a response, and I know I will receive an input stream because it's an image what I get as a response. So I have that. Now I will make this one public, and I will actually implement the abstract methods. There we go. Then I will assign this asynchronous context to a field. So I have the field with the asynchronous context, and these two methods over here, the completed and failed. Whenever the Jax-Rs call completes successfully, I will be called with this. I will have this method called, and if it fails, I will have this other method called over here. So first, the simplest one is when it fails. When it fails, I don't want to show any weird stuff. I will just do a nothing context dot complete. It will say, okay, the request has been completed, and you don't have to do anything. Okay. Now, when it completes, when I have the actual input stream, I want to write that input stream to the asynchronous context, the response. So what I will use is use the Java 7 syntax to actually get the output stream and have the auto-closable. So I will do just this. Just in case of an exception, I won't do anything. Exception. Okay. For now, and I am not willing to do anything, so let's put that there. Fix my imports, and there we go. So I know that with this, I will have the auto-closable support. I will have an output stream, which I will use the asynchronous context, get response, get output stream, which will be closed. And the input stream, I will just assign it directly, so it will be closed as well, this try catch block. So what's REST is to copy those two streams. This code actually does that. It's just a simple read from the input stream and write it to the output stream. And this will actually make, will actually show the stickers on the left this time around. Okay, now it is being shown. Now I have the stickers here, and they generate a lot of REST calls. The first one is getting all the stickers from the server, which are these 9 stickers. And then we have an independent REST call that actually gets me these stickers in position here. And I can actually look at them. If you want to play with the code, try removing the asynchronous support from here, and you will see how slow your server becomes, because you will actually create the requests, and you won't be freeing any resources while the requests are happening. So this is a very easy way to actually optimize your resources, since you are freeing the threads that are handling the request, and you are using callbacks. So you are actually just handling the streams, not the actual threads. And this will actually improve performance a lot in your applications if you happen to find this scenario where your servlets become unresponsive because they are waiting for some answer from the REST server. This can be used as well on JSF and in other places. So let's see how the application works right now. So I have this here, so let me open a new tab. Put it up here. Let's access the same URL. So I say that it's a collaborative sticker book, so if I drag this alien over here, I will have it here. Perfect. If I drag this moon over here, I will have it here. As you can see that it is replicated. But there's an issue. Right now, there's no persistence, and there's no state saved. So if I refresh the pages, I start fresh again. So if I refresh this guy, I don't have the astronaut there. If I put this little kid guy here, he's alone in here. Well, he has some friends over here. Why is this? Because we want to save the state on the REST server as well, and we are not doing that right now. But where does this happen? This happens when you drag and drop stuff. This happens on a WebSocket. So you can also add REST calls to WebSockets. So let's do that now. Let's open the WebSocket class, which is actually on the sticker story project. We have the story WebSocket class. And here we have a common WebSocket. We have seen so far a JSF managed bean, a servlet, and now we have a WebSocket. So whenever when user drags and drops the sticker, this method is called. So the sticker is sent to everyone else. That's cool. And whenever someone opens a session, you just add it to the list of sessions that has to be notified that you drag a sticker. So we want right now to actually add some kind of persistence or some kind of notification to the server that a sticker was dragged. So you get this method called every time a sticker is dragged to the screen. So we want to actually call a REST service for that. The URL that I am thinking of is this guy over here. So let's say string URL equals this. So I will call the story resource in this server here. And I actually will do a post HTTP call here. So I know that I to do this kind of calls, I have to create a client with the others. So I create the client, I fix my imports, and then I create the target. So client.target, and I will say the URL is my target. And then I know that I need a request. I am expecting to receive nothing from this because it's a post. I'm just posting stuff, so I won't put anything inside the request. And I will send a post method call. And as you can see, it receives parameters. It receives an entity. The entity is the actual content. So I need to send content as the post body. So I will say entity, and I will send the JSON representation of this sticker. And I know that the media type that I am sending is an application JSON stuff. So far I have this, and I just have to create a JSON sticker representation of this sticker object, which is the one that I received whenever there's a message. So I will actually create that by using JSON object, JSON sticker equals JSON dot create object builder. So I create the object builder, and then I will just add the parameters as with any JSON processing API. And finally, I will just build. Fix my imports, and there we go. So with this, I create a JSON object representation of my sticker object by setting the actual parameters of the actual attributes of my JSON object from my sticker, and I will send that using a post request. And this actually does the trick of actually sending stuff to the server. So now supposedly we save we send every time we put a sticker here, we send something to the REST server. Now, how can we verify that? We have to verify that by getting those stickers from the server. So the best place to do that is whenever we open a connection. When we open a connection, which is when we refresh the page, I have to get all the stickers that I had on the server. So how do I actually do that? Well, we can actually do a simple a Jax-Rs 2.0 client invocation. So I will make this as a one-liner. So let's put JSON array, which is what I expect to get. I expect to get the JSON stickers on the server equals client builder dot new client dot target. And the URL that I want to use is the same that I have here, but instead of doing a post, I will do a get request. So far, let me add this as another line, and then dot request dot get, and I know that I need to get a JSON array dot class. Also, my request has to be media type, and then the application JSON. So look at this code. It's a one-line well, a one long line invocation. You can create the client, the target, the request, and do the get, chaining the method calls. So you can have one after another, and you don't have to break your code into multiple objects. Like here, you have the client, and then you create the target. You can actually do everything just in one single swipe. And then I will just convert the JSON array that I got from the server uh, into actual objects that I can handle. I just copied this method from something that I have prepared. But in short, what it does is it iterates over the stickers, and then from them we get the JSON objects, and then we populate new sticker objects with whatever we get from here. As you can see, this is kind of the same as what we send here. It's the opposite. This converts a sticker into a JSON sticker, and this converts a JSON sticker into a sticker object. Then we just send the objects as usual using the session. So we get all the stickers and we send it to the connected session using these lines over here, this is standard WebSocket API, and this is JSON API, and this is the Jax-Rs API. So right now we should see these things refresh, right? Every time we send a sticker, we should refresh and see them. But we don't see that because we haven't implemented the server yet. So let's take a quick look at the changes that we need to do on the server side. So let's go to the story resource class here. And you can see that here I have the list of stickers that I actually handling. So the first thing is whenever I send a sticker, I receive a sticker object, a JSON sticker, I have to convert that to a sticker object. So it's really similar to what I did on the WebSocket. I create my sticker object, I separate the values to it, and then I will just add it to my stickers list. So I add the sticker. And then I will need to convert this list of stickers into sticker objects and put them inside a JSON array. So if you remember how we did it with the list of images, I do almost the same stuff. I just create a JSON builder, a JSON array builder. I do array builder.build here, and then I will just iterate over my stickers here and convert them accordingly using the object builder. So this will create the stickers, the sticker array as JSON. Let's look at the application, how it works now. Let's refresh, and let's drag a moon over here, and an astronaut at its side. And now let's refresh, and I have them persisted. Why? Because it's being persisted on the REST server using these simple lines of code. And the actual WebSocket doesn't really know about that. It just makes some REST calls. I can open it in a second tab or a window, and I can actually see that they are there. And if I am late to the party and I just refresh the page, they are still there. So let's do a quick recap of what I did. I implemented JSON, Jax-Rs clients, mostly with JSON, in the web application inside a JSF management, just as usual. Inside a servlet, optimizing resources using asynchronous servlets and asynchronous REST calls. And finally, inside a WebSocket, using simple calls over here and here. Then I also added to the server for the sticker resource and the story resource class, I added the necessary conversions from objects to JSON using this code over here for the stickers that are persisted, and this code over here for the images and the sticker list that are shown on the right side, well, on the left side of the page. So you can see how this actually works. Well, this concludes the tutorial itself. As you can see, Jax-Rs 2.0 client support provides a simple and flexible implementation for invoking RESTful services. Let me go back to the slides. And, well, Java EE7 actually is more than Jax-Rs 2.0 and JSON processing. So download the Java EE SDK and begin developing applications with Java EE7 today. You can find the SDK as well as comprehensive documentation at oracle.com/JavaEE. Here, Glassfish 4.0 is an open source server that runs Java EE7 applications. It contains the full or web profile specification implementation. Download it and test your applications. You can get it from www.glassfish.org. Here. Java EE7 contains a lot of new enhancements. Give the platform a test today. Talking about the technology in Java EE7, did you notice something that could be improved, or perhaps you have a great idea for an API that could be incorporated in future versions? Make the future Java. Join the Java community process and be part of the joint effort of creating a better and more complete platform. Remember, Java specifications are open for people like you. Get involved and join the community. Join your local Java user group and be part of the vibrant Java community. Learn more, exchange ideas, practice techniques, and adopt a Java specification request for the next generation APIs. Now, did you know that Oracle provides free demonstrations and tutorials about Java EE and other technologies? A poll will be posted on your feed to get feedback from you on your experience from the Oracle Learning Library. Go to the Oracle Learning Library to find out about all the free material available. You can find tutorials like this one, as well as online courses, examples, articles, and much more. You can find this recording as well as the previous ones in this series in the Oracle Learning Library site. Please answer also the poll posted on your machines about how did you find about this event. This will help us find better ways to reach developers and provide better material. A final note, if you want to learn more about Java Jax-Rs clients using JavaFX desktop applications, go to the Oracle Learning Library and look for the Oracle by Example tutorial titled Developing Enterprise Applications with JavaFX and Java EE7. Just go to the site and search for it. It contains a cool example of how to connect an enterprise application with a JavaFX application using Jax-Rs 2.0. And well, that's it for today. Thanks for your assistance. My name is Eduardo Moranchel, and it has been a pleasure to be your host. Have a great day.